Yes, thank you. And, um, good morning, everyone. Okay, today, my session is going to talk about how you can develop the product, right? And in this topic, I'm going to talk more about drone or UAV, right? Or autonomous. Drone. So, when we talk about product development, the most important thing that I wanted to highlight is everybody have a concept, okay? And when we have a almost everyone would have dreamed about some new concept, but a lot of time the biggest challenge is how this concept is going to work in the real world, how we can make it work, and how expensive it is, right? And how many times I make this prototype and see how it works. These are the biggest challenge, and these are the biggest thing that prohibit our dream to be realistic. So we have solutions that can help to validate the concepts in the much early stage before we even start to think about a prototype, so that we can check that our concepts are uh, feasible concept, or can we make some changes and make it work. So I'm going to talk about this, but before I start, I want to just give you a small video from what I'm going to talk in the next 20 minutes, right? So just let me play this video. This will give you an overview of what we are doing. Thank you for watching. So this gives you a overview of what I'm going to talk. So if you see that in the very beginning of the video, from the early days of the flight, the mechanism or the physics that is used in the very early stage of days of flight, it's just a mechanical things. So, how the structure takes the man to fly. But if you look at that today, it's all about electronics, mechanical, hydraulics, pneumatics, and then controls and all. So when we develop a concept, when we want to verify these all have to talk together. they all have to communicate, and we all need to verify this, whether it is a drone or a UAV, right? So this is where that the simulation helps, okay, because the prototype is first of all, it's going to take a lot of time. The second thing is also expensive. I think, especially if you are developing a drone, I think I don't need to explain how expensive it is and how much time you are spending for one prototype, right? So that is the painful. So imagine that how much time it can help. It is most important things. Just okay. So okay. So this is the place. So this is a place. Time is key, right? Especially when we are starting our business. The time. Okay, who comes with a better concept? Who comes to the market faster? That is a very important. So right now, when I am talking to you, you can see the number of that the designs across the world, right? How many concepts are being in the market, and how many players are developing a different kind of propulsion systems in the market. That's a thing. So if you look at the history, those doesn't make those who create an innovative product doesn't always win. Okay, those who bring innovative first to the market is always the winner. Okay, so this is a place the simulation helps few things to bring the product to the market faster. But when we do this, there are a few things I am sure that you all encounter, right? So the first concept is when we talk about a drone, it's all about electrical propulsion. Okay, most of the time we don't call conventional fuel as a drone. We hardly see, right? So most of the first important part that what we want to verify the performance is in the electrical. The second thing is how this product is going to work in the aerodynamics, thermal, and other things like avionics integration and as well as cooling. And if it is autonomous, we also want to simulate the autonomous behavior, right? How it takes sense and how it calculate, and then how it drives its calculate its path and so on. Then the last one is verification and certification. This is most crucial. Okay, and a lot of time, you may have a very nice concept and as well as the prototype, but if we cannot bring to the market or if it is not useful to usable in a particular country, we are losing the market. But at the same time, we cannot just avoid, because certification is very crucial in this. Because imagine if you are going on the road and something fall in the sky and it is very dangerous. So nobody allow also, right? If there is such a security threat, if because of the battery drain and something fall from sky, or if some propeller blade gone out and then, so these are the serious security things that we also want to verify these and certify that it's safe to operate in a country or in that particular application. So when we talk about all these challenges, and if you look at the across the world, there are a lot of regulations as well, right? Different countries, and for example, if you talk about USA or ESA, there are certain regulations that to make sure that this product is safe, or this product can perform as it is. Right? So like this slide talk about some of the things that how this product should behave in the structural aspect, how this product should behave in the flutter aspect. Right? So like this takeoff, and not only that. Electromagnetic is one of the serious things. Imagine if the drone is flying in, if there is a lightning strike, okay, or if there is too much noise in this, people get annoyed, So when imagine if somebody orders some item in the online, and the drone is delivering some item to the neighbor, and it is too much noise. Nobody can take it. So it's all this. So these are the things that need to also make sure that the new concept not only just fly, not only just lift what we want, but also it meet all these regulations and necessary objective for product design. So this is just an example, right? So how ESA classify the safety, right? So one of the things is an open category, and this is quite not very risky. But if you see the second category is a specific, and that goes into a little bit more detail. And then the next one is a certified category, especially very big drones, and those are all need to be operated with a license and so on, right? So how they categorize from less significant and lightweight to the bigger size, and how this is being regulated in the market. So why I am saying this, because when we design this, we cannot just look at the product alone. We also look into how this product need to make sure the regulation requirements for the market. So here, what we are doing in this, okay, so you have a concept, you also have a regulations to meet, and how this could be validated before you start to build an expensive prototype. Okay, in another word, before you cut the tree, you just sharpen that, right? So you make sure that you make that your concepts are everything almost right, okay, in the conceptual stage before you build the product. So here we are talking about a different physics, okay, in the product development aspect. So one of the things that the main challenge is maybe no one do everything, right? A lot of time we buy batteries, or we buy electric motors, we buy propeller blades, and all. The most important thing is these all have to work together. So when we want to make sure that all these things are working together, we want to make sure they are properly designed. So we don't want the motor to be too powerful so that it doesn't give you a sufficient flight time. We don't want the battery to be too heavy so that it doesn't live, right? So there are things that we need to balance it properly to meet the requirements. So if the battery has to be lightweight, the battery also have to give the power for sufficient flight times, and so on. So here we are talking about multi-attribute balancing. Okay, so each and every attributes are properly designed to meet that certification, regulation, and as well as the product design. So if you are developing a drone that can carry X kg of medicine, or if you are carrying maybe any specific number of payload, then it has to meet that distance and as well as the flight time. So here we are offering some of the solutions. If you see here, battery sizing tool, this will help to simulate the battery behaviors. So if you are buying batteries from supplier ABC, and based on that, their specification, which battery can help me to fly 40 minutes or 50 minutes. Okay, and with this motor, if I use supplier ABC motor, which by using this supplier ABC batteries and supplier ABC motor, how long I can fly, how much lift capacity, and those are my requirements, and I can validate my requirements against my design and see whether they are meeting it. The next one I also want to talk about attribute optimization. So if we talk about a few other things like a noise, thermal behaviors, these are also important. The flight may be, or maybe the drone flies very nicely, but imagine if the drone is not properly sealed or waterproof. Imagine in the rainy days, it can easily get spoiled by the water when it's. Same thing, it goes into another case of noise, okay, especially when it flies in this nearby. So here we virtually validate the designs that you develop, and these validated models act as a digital twin of your physical twin. So they behave exactly how your real product is going to work. So talking about this, I'm going to talk few solutions that can make that can predict how your drone is going to work. The first important topic is the aerodynamics. Okay, without this, the drone won't fly, right? So we need to simulate how its propulsion system works, how its body behave in the airstream. So here we are offering a number of solutions. If you see here, this slide shows that the number of concepts. So people may have a different idea. Okay, 3 propeller, 5 propeller, or maybe even VTOL, vertical takeoff and lift. All this is need to be validated. Okay, so here we are offering number of solutions. If you look at this, is one of our customer, Jobby Aviation, and you can see that the propeller concept they use, the propeller that VTOL. So that can automatically align in the forward direction and as well as the vertical direction. It's a bit unique concept. If you look at the 30, 40 years of the conventional propulsion takeoff helicopters and all, hardly you see this concept. But here it's a single propeller that can change the directions, and it makes that innovation. But how do they validate? And this simulation helps, and it helps to reduce the prototype and as well as the concept. Then the second one, I also want to talk about structural concept. Okay, structural is most also important, like aerodynamics, because the drone cannot be too heavy, but at the same time, if you make it too light, it can also come into other consequences. If you are going to load it with certain components, if it's supposed to carry certain weight, or even in case if it drop with a certain height, it need to withstand it. So here the structure going to get the loads in different aspects. During the landing or flying, it comes to certain loads. This need to be validated. So here is where we are applying multi-physics. So if your drone is going to get the load because of the fluid or air environment, we can simulate the air flow and we can simulate the load acting on the structures. But at the same time, certain components or mechanisms, if it is supposed to carry certain load, or if it is having some mechanism to pick and place, you may also have a physics to calculate that loads acting on the structures. And not only that, the drones that flies in the air, there is also another phenomena, flutter. Okay, flutter is another one complex phenomena. Right? So the structure may be very strong, but because of the high speed travel in the airstream, the air dust can trigger oscillation in the structures. So we can also simulate that the flutter phenomena. This flutter phenomena is also important for the certifications. Okay, so on the flight envelope, you need to make sure there is no flutter happen at that particular envelope. So all these are possible, right? So here I'm going to talk about some of the capabilities related to how we simulate the flutter. Okay. If you are dealing with certain small components, certain small drones, probably toy, it may not be important factors, but if it is a quite big size drone, it is a very important, because the structure can easily trigger the flutter phenomena in the structures. Okay. So here we talk about how that the fuel combinations in the wings and how that CG position where it can trigger the flutters. Then it can also simulate few other things when you have a composite structures at a different resonance at the different air environment, how this air stream can oscillate, make the structure to oscillate and trigger the flutter. Then you also see here, this is the typical workflow in the aerospace industry. Okay, there are certain things that we need to make sure the structure is safe. One of the things that the first one, if you see here, ground vibration test. The ground vibration test is, if you take any flying object, before we start to fly, we make that the structure to vibrate exactly like how it is going to experience in the air. So we have a solution that can simulate that in terms of the simulation aspect and also the test wise. So we have the hardware that can excite the structures, and it can see that how the structure is going to behave in the particular frequencies. Then you have a comparison. So you start from the simulation, then you goes to the test, and you make sure this process is completed to make sure that it is going ready for the certification. The second thing is also like an iron burn, right? And goes, and then you can extend this process to that the flutter simulation and as well as the test. So then the last one we talk about the wind tunnel test. Okay, the wind tunnel test is more on how this the flying object experience the lift and drag force. But doing this in a physical world, it's expensive depending on how big your drone or how big your structures. But at the same time, if you do it in the software, just a few hours, you know how much lift you are going to get and how much drag force you can get it. So this combination of physical and as well as the simulation makes your product ready for the particular certification. So now I go in a little bit detailed test, right? So when we talk about the simulation, yes, we know that this product is going to behave like this. This is stiffness it's going to have, its frequencies that it's going to vibrate. But how do we make sure that this is conformed, right? This is where we use the physical test. No matter how good we develop the product, still before we go for the certification process, it's a final test, okay, to to make sure that this product is verified. And this is the place that the test we are using a simulation injunction with the test. So how it is, okay? For example, if you take a very big drone, probably you need a lot of sensors to measure how this is going to vibrate at the different frequencies. But here, what we do is it's called pre-test. So pre-test means you already have simulation models that this drone is going to behave at this frequency. This is going to have an excitation at that particular edge, or in the middle of the wing, or in the middle of the propeller, or in the. So we, based on that, you can determine the number of sensors and accelerometers. You can virtually place it. Then you can use your shaker to shake and see how this drone is matching your simulation results. Okay, what is the advantage? If I don't use my simulation model, I probably do a trial and error. Okay, and I always believe my physical test is accurate, but the physical test may not be accurate because I may not put the right sensor at the right location, because the particular component or maybe particular the structure doesn't have enough sensors to capture its resonance or its excitation. So this is the place we leverage the simulation results. If the simulation result says that this structure is going to behave or going to have an oscillation at 10, 15, 20 hertz, when you do the physical test, you know where are the sensors and where to put the sensors and how many sensors you need it, so that you capture all the three modes at one shot, right? So you don't miss anything and you don't repeat this. So you can make your physical test more efficient by using the simulation model, right? So these are some of the examples how we test, right? So this is one of the UAV setup. So imagine the size is that around 5 kg, and you can see the size of the wingspan is around 5.8 meters, and then the range is around 160, and the fuselage is around 0.5 meter. So now you look at that, every test, it is important, how many sensors and so on. So the solutions, what we offer here is a SCADA's data acquisition systems, and you also have the software called Tesla. So what this system does is it captures the data from the drone or UAV, then it collect the data, and then you need to also process that data because different channels comes excitations. So we use this test lab to process this. So test lab is a software that handle all your test data, whereas the simulation data you already have it. By combining these two, test data and as well as the simulation data, you know how accurate your simulation model is. Okay. A lot of time there will be a variations, right? So these variations could go for that how there may be a variation because of that number of things that the air surrounding, or maybe the moisture or the damping, all this. So even the mesh size. So this mesh size, this mesh size and all can be automatically refined for to match with your test results. Why I should do it? Because if I know my simulation model very close to my test results, my next simulation model can be more accurate. The lesson learned from my current simulation model. That's how you can minimize the test. Like this, there are a number of test requirements. If you are doing it the structural side, you need to make sure that the structure is suitable, withstanding in sine loads, random loads, and also the impact loads and all that. So all these loads can be applied for the structural simulations. Okay. Then this is the place where we compare the results. So we have a test results, we also have a simulation results, and we compare these two and see why there is a difference and how we can make it more closer to the test. Right? The next one I wanted to talk about update. Right? So this update is the one I was talking about, improving the model, right? So make the simulation model closer to the physical test. So finally, I wanted to just quickly cover this whole structural aspect. When you want to talk about the structural component, we need to make sure it's strong in stiffness, it is strong, it withstand that in the vibration, it withstand in the flutter, all these. But even though these are all different physics, different simulations, but our goal is to get the certification, right? We need to make sure this, and how much they are all connected is important, right? So that I don't spend too much time on simulation also, right? This is a value of. So I want to talk about one of our customer, right? This is Northrop Grumman. This is a US-based defense customer. They also use extensively make use of the simulation tools to make the structures grow. Next one is talking about the electromagnetic. All right, so this is one of the other common challenge. Okay, imagine if the drone is flying at rainy conditions or thunderstorm. We want also to make sure that it doesn't get affected by the lightning. So I wanted to talk about how we can capture that, how we can simulate this virtually, how you can apply the drone and with the lightning effect, and see how this current is causing. So if you look at here, there are different number of lightning conditions. So you can trigger on the structures. You can see how this is the current passed through the wire harness and so on. Then you can also see that how the current is being distributed on the surfaces and so on, right? So this will help to simulate that lightning effect on that. The next one is I'm talking about the acoustics. Okay, acoustics is another one annoying factor, right? So we want to eliminate from the propeller. So the acoustic simulation capabilities simulate the propeller noise, and not only that it simulates the noise, but it also simulates how far it can travel and what is at the dB level at the receiver end. And not all the noises are acceptable. Of course, we cannot avoid the noise, but we want to make sure the noise is not too much annoying at that frequency what we don't like, right? So we also look at the frequency ranges that this particular drone and particular propeller is making. And not only that, we also identify the sources, because if you see here, that the source is very important, because it could be from the air noise or it could be from the electric motor. So we identify which is the one. Is it motor need to be redesigned, or is it going to change the propeller and so on? We simulate that. You can see the noise, right? And you can see our test equipments, and as well as the simulation, we are able to simulate the frequency and dB level. And this is also one of the regulation in some of the European airports. The noise level cannot exceed during the takeoff and landing, right? So this is one of our test equipments. If you see here in the right side, this is called sound camera. So if you move this over, it can identify which component is making the noise. If you normally what we do is we just hear the noise, okay, but we don't know which part is making. So here we can identify which part is really making and how the sound is transferring to this. Is it through the bodies or is it through the air? And we can simulate that in the solutions. Next one, I want to talk about the heat transfer, then how the electronic equipments generate the heat and how it can be dissipated, because that is also another one phenomenon, right? Then I also want to talk about integration, right? This is the most painful area. So if you're buying from different suppliers, you may have a concept. If you see here, there is a concept using a 3 propeller or 4 propeller, right? And which is the most efficient, which is the power, should I use the 3 bigger motor or 4 smaller motor, right? So these are the few things that always we have a challenge. We cannot buy every 4 motor or 3 motor and different propellers and spend the money on that. So this the simulation helps to see in early stage, is this concept is good or is this concept is good? Then how I can make my propeller very efficient. If I use my gear ratio different, can I make it fly more efficient, right? If I change this bigger motor to smaller motor, will I save my battery or not? All right. So these are different things that we can simulate. And this is one. Finally, we call it as a virtual integrated aircraft. We integrate and we can simulate hardware in the loop, model in the loop, so you can see your control algorithms are validated with the rest of the systems. Okay. So the last portion I want to talk about how we can verify this, everything what we talk, structural, vibration, flutter, and all. This is one of the process that is important for the certification. So before we go for certification, we say this we put the tick mark. Okay, this is passed. So in this solution, we offer a extensive test solution or verification solution, and Airbus is one of our customer, right? So they follow our process solutions. One of the solution is the flutter solution. They make sure that the flight envelope is covered within the flight and avoid this. And last solution I wanted to talk about is an exploration, right? So the exploration is a very key, because in this simulation, we give inputs, we have the concept that the simulation tools will help you to say, yes, this is good or not, that's it. But how do I make my ideas or my concept to be most efficient to meet my requirements, right? That's where this is a kind of exploration technology. So if you put this, if you see here, you may have one concept. You can throw this to the tool, and then you say, I want this drone only flies to 10 5 kilometer, but my goal is a 10 kilometer. I have a concept, but now I have a 4 propeller, but the 4 propeller I can make it bigger, or I can make it smaller, or I can make it even 4 propeller to 10 propeller. But what I need is 5 kilometer is not acceptable. I need to go to 10 kilometer, and I need to lift 50 kg or 20 kg or whatever. If you set this tool, you can see here, it takes your inputs. It knows how your physics works from your simulation tool. But what it do is automation. Okay, so it automate your process. Instead of you do trial and error, this tool automate the repetitive task, and then it comes with the highest thrust models and highest range models, depending on what you set it as a goal. Yes. So that is all about some of the simulation tools. I also want to share, we have if you go back, we have programs for those startups, and we also have programs for academic institutions. So those who want to adapt these technologies, right? Whatever I showcase, especially if it is academic, we have a very very well established learning curriculums, so that the professor or instructor can assign the courses for the students to learn. And another thing is we also have a endorsement. Okay, that is, once you get these courses, we have once the professor acknowledges and endorse, there's a LinkedIn certification from Siemens also. You can tag with your profile for lifelong. Okay, it's a kind of certifications that you can use for your career and so on, right? Then same thing goes for the startup. We know that all these bigger players at long ago, at some point of time, they started as a small shop. So at that, we know that a lot of innovative ideas come. So we are encouraging to leverage our startup programs. We have whatever I am talking, it's a solution, complete solution from concept to the validation to the certifications, and we have this startup programs. So you can see one of our customer case study before I conclude my presentation. Right, this is one of our customer who leverage how they bring the concept for the.
My name is Zachary Hazen, and I work for Martin UAV. We've been working on the VBAT, which is a vertical takeoff and landing UAV. We're asked to get products right the first time, and our customers want results that benefit them in a timely manner. So far, we've been using SimCenter Star CCM Plus for developing the next generation duct for the VBAT family of aircraft. We'd start with, lower order tools, handbook methods, and our experience base, and we would prototype and build and test on a static thrust stand. We would also go and fly, and so there'd be a lot of building and a lot of scrapped duct designs that perhaps didn't work. Martin UAV landed with SimCenter Star CCM Plus simply by validation. Support engineers. So I'd say the best thing about SimCenter Star CCM Plus is in the array of tools that it offers. I can choose between a simulation that converges very quickly and gives me answers right away from first principles, and I can also run very detailed simulations. And so I can choose the appropriate methodology I need to solve the problem I'm working on, and I'm not fixed into one kind of approach. Yeah, so when I was looking at designing a new duct for VBAT, we looked at quite a few by hand, maybe a handful of designs. Then things got pretty big once we let Heath go at the problem. And then it was iterating through hundreds of designs, and for each design, it was doing several runs of hover and cruise conditions. So if you multiply it all out, it's many thousands, if not tens of thousands. We can actually understand our product better, whether it's the baseline design we already have today or a future design. I see the high fidelity simulation as a way to stay ahead of the demands we know are coming. We can anticipate people are wanting to carry more payload, more fuel, fly for longer.
So this gives an idea of how the simulation helps, okay, in the concept stage. You have seen the product, which is very innovative, and also we may have an idea, but how difficult to test this, and a lot of people have a doubt whether this will work, and we can use the simulation technology to bring your concepts to the reality. Yeah, that's all about my solutions. Okay, whatever I covered is within the short period, I just highlighted few bullet points of our solutions. If you are interested in any of the specific solutions, feel free to reach out, reach out to us. Right? Yeah. Thank you all your time today.
Thank you, everyone. So we will be having a very short break, and after that, we'll be having another very short session on autonomous robots, autonomous mobile robots, autonomous ground robots, and of course, Winston will be having this one shorter version of what he does. And of course, you can have coffee. But when you have time to ask or you have any inquiries and so on, please raise them perhaps at the end of the session or within the session as well. So, have a quick 3 to 5 minutes break. And after that, we'll continue here. Thank you.